Hello.
Yes, sir. Zain, sir, I'm here. I was on call.
Okay. Should I
Mhm.
start or should we wait for us for
Yeah,
some
we
time?
can start. We can start, sir. We can start. I'll start.
Okay.
So, yeah.
Okay. So today we will be discussing on how to do the detailing of a block diagram. Okay. Uh, and I'll just take what we will do in this session is we will take a small example. Okay, of a system. The system I have in mind is a very simple one, which is a device, okay, which is there to which will switch on a pump or switch off a pump depending on inputs that the users. So the user through a mobile app can see the pump and then switch it on, switch it off remotely. Okay, so this is a sample system that I'm going to be discussing, and on that we will just review the block diagram and then go deeper into every piece of it. Okay, or at least one piece we will take, one module we will take, and then we will do the detailing of that. Okay. Uh, if you have questions while I'm speaking, you can type it in the chat window. Okay, fine. So I'm just going to start the presentation. So like I said, this is the agenda. We'll review a block diagram of a simple system and then do the detailing of the components of the sample block diagram. Okay. So this is the high level block diagram of a system that allows a user to control a water pump remotely. So there is a device which is going to be controlling a water pump. There is going to be some server that is going to which the device will connect to, and the mobile app will also connect to this server so that the mobile app can control the water pump. Correct? The items that are in blue are items that we are going to be building. The item which is in white, that is the water pump, which is remote, which is something that we are not building, which is going to be some ready-made water pump that we have. Okay. So then what I have done now, okay, is taken the device and zoomed it in, right? And this is how the device block diagram looks like, the logical part of it. Yes, there are certain components missing here. Like a configuration manager would require some kind of a storage system or something like that, right? And maybe a logging system that you want to say, okay, when did the user send a request or whatever, right? But we'll not look at that. These are the major components. This is a minimalistic system, so minimal this much so is going to be required. The communication manager is responsible for communicating with the server, right? So that communication manager helps the device communicate with the server. The pump controller is the component that controls the water pump, so it can switch it on, switch it off, right? Uh, this main controller is just the main bot, like the main application that you will be having, which will stitch everything together. Configuration manager is to tell what is the ID of this particular device. If we're going to have multiple devices deployed at different locations, then what is the ID of this particular device? What is the what is the address of the server? How do I connect to that? Uh, Later on, if we are going to have multiple water pumps connected to one device, maybe IDs of the water pumps and any other communication or any other modules, whatever configuration parameter or anything like that we have, that would be saved in the configuration manager. You could have like an LCD UI so that you can set the values of the configuration manager and things like that. But for now, let us assume that is not there, right? And we'll do it with some buttons or something like that. That is also possible, or the mobile app will also do it directly or some things like that. Fine. Any questions, any doubts till now? Anyone?
Sir, sir,
Yeah.
hello. Sir, this detailing of block diagram is related with our architecture diagram and user flow.
Now this is more for people who have embedded projects, embedded systems projects. You would have a task in your project plan saying detailing of a block diagram.
No, sir, we don't have such task, so this is not for
You
us.
are not, then it is not for you. If you want to still sit through this discussion, you can. Otherwise, you can drop out if you want to. Okay.
Great. Thank you, sir. Thank you, sir.
Yeah. If you have a doubt, you can put it in your chat in the chat. Okay. I will take a look at it and answer. Okay. Now, the next thing I want to do is I want to look at each module. At least I'll pick up one module at a time. Okay. And we'll try detailing that. Okay. So the next one, let us look at the first module, which is there is the communication manager, right? Now I have a choice that I need to make. Okay. Since I'm saying this is going to be a mobile app and it can be this mobile app can control this device from anywhere, it is obvious that I'm going to be needing the internet to do this, right? Uh, and I'm going to be connecting via the internet to the device. Now the device has two choices, right? One, uh, depending on where the device is located, it could be connected to the internet via a Wi-Fi network that is present in that location, right? Or it could use the GSM network or something like that to connect to the internet directly, right? Without being connected to a local Wi-Fi network or a local area network, right? Even if it is not Wi-Fi, I could use an Ethernet and also connect to the local area network. So effectively, I have two choices, right? So I have two choices. Uh, First one is connect to a local network, and that local network will allow me to connect to the internet if there is internet connectivity available to that local network. If not, then not, right? And the second option I have is I can connect to the internet directly, right? And that I can do via some GSM module or something like that, right? Which is the hardware that I'm thinking about, right? Now, other than this, okay, so this is how I connect to. I'm thinking about the actual physical connection. The other thing that I need to be thinking about, right, is uh, when I do connect to my server, uh, how am I going to communicate? What language, like effectively, what networking language am I going to use? Right? Am I going to speak to it in English or Hindi or Marathi from a network perspective? So what I'm trying to get at is what is my how is my messaging going to work? You know, will I be sending uh, the first byte will it be device ID? The second byte will it be something else? What will how will my message be structured? Okay, so that I can communicate with the server and the server understands me, right? So I need to be coming up with a message format or basically the protocol with which I'm going to be speaking from the device to the server, right? So that and that protocol needs to be implemented at this within the communication manager and within the server so that the device can communicate with the server. So I need I need a messaging protocol for server and device to communicate, right? Now, when I so this is the second thing that I need. Now, when I look at the communication manager, right? I see that the main control system will be speaking to the communication manager, and the communication manager will also be speaking to the main control system by providing it events, right? So you could do this separately and say that there is an event manager, and the communication manager sends events to the event manager, and the event manager then raises those events, and the main controller is just asking the event manager what to do or things like that. But in this case, what I mean by event is the server will send a message to the communication manager. The communication manager will receive this message and will tell the main controller, right, that I got so and so message, right? Uh, the main controller, okay, might use another uh, block module which says, okay, this message, what does it mean and what is the meaning of this message? Does it mean I should switch on the pump? Does it mean I should switch off the pump? Does it mean I need to go and change a configuration with the configuration manager? Right. So let us, just put that thing there. Let's say this is like a command manager. Okay. Command or message manager. Right. And now this guy is going to help the main controller, right? Uh, in telling it that okay, this message that has come, this is what it means, this is what needs to be done, right? And then based on that the main controller will move ahead and do that. So the communication manager uh, needs a way of receiving, so it needs a way of doing 4 5 things, right? So let's list those down. So what does the communication manager need to be able to do? It should be able to uh, send a message to the server. It should be able to receive a message from the server, right? It should also be able to detect if the message that it sent was received or not received by the server, right? So detect if message was received or not by server, right? This is the minimal thing that we need, right? Is this hardware block diagram or software block diagram? We're still at the logical phase only, right? We're just logically thinking about. Uh, we looked at this diagram, right? And then we're looking at communication manager and trying to detail out what is going to be required by this communication manager, right? So that is what it is. So Abhishek, have I answered your question? I'm saying this is not hardware or software right now, right? We're just detailing it out. Okay. We're detailing the communication manager right now. So we looked at this is the block diagram that you would be at, right? Uh, in your block diagram task, you would have built a block diagram that looks something similar to this, or is there. So is there about it would have been for this particular problem. The problem is uh, a system where the user can control a water pump remotely through a mobile app. So this is your highest level block diagram where there's a device, there's a server, there's a mobile app and a water pump. The device is connected to the water pump, and through the mobile app via the server, we are going to be controlling the device, and we'll get to know the status of the device also through the in the mobile app through the server, right? So this is your highest level. Then we moved one step deep. We went in a little more deeper. We said that okay, now the server is there. Server is going to be communicating with the communication. Like, how is the server going to be communicating with the device? So there's a communication manager that is going to be there. The device needs to speak to a water pump, so hence there's a pump controller which is going to be controlling the water pump, which is a outside piece for the device. Then I said there's going to be certain configuration parameters, like what is the address of the server, what is the ID of the server, what is the ID of this particular device, uh, you know, maybe certain other information that could be controlled or are configuration parameters that would get saved by the configuration manager. We have this main controller FSM which is just stitching everything together. The command manager or the message manager is just responsible to tell that okay, once we receive the message, what is the command within it? Is it a valid command? If it is, what is it? Is it to switch on the pump, switch off the pump, so that the main controller then can, communicate with the pump controller, right? And then after we did that, we looked into the communication manager. We went in and we said, okay, communication manager, what do we need to do there? We said we need to talk to a server which is going to be remote, right? Which could be anywhere. And since this is what we need to do, this connection and this connection is going to be via the internet, right? Uh, because it is not going to be a one to one connection. It's going to be via the internet, right? And we're going to use the internet's infrastructure to have this connection and this connection. So now I have two choices. One, I connect to a local network, and that local network gives me access to uh, to the internet. So this is, for example, like how you would connect to the internet sitting at home or with your laptops in college or in at home, right? Your laptop has a Wi-Fi connection or an Ethernet, card or something like that, and using that you connect to your local network, which is, to your router or a Wi-Fi router or something like that, and then through that your Wi-Fi router, which is connected to your internet service provider, hence you are connected to the internet, correct? The other option is I could say, I'm not connecting to any local area network or something like that. I'm going to be connecting directly to the internet using a telecom operator or directly connecting the device to a service provider via GSM module or something like that, right? These are two choices that I made for myself. There could be more. I haven't thought of that. I'm not thinking of that. I'm just constraining myself to these two choices, right? The second thing we thought was okay, since this guy needs to talk to this guy, right? Uh, we need to have okay, once I know I'm going to connect via the internet and all of that, I'm going to use that infrastructure to connect. But once, how do I actually speak to the server? How do I say, hello, server, how are you? Uh, the pump is currently on, the pump is currently off. Okay, do you have any message for me? Say the mobile app sends a message to switch off the pump. Okay, communication manager gets that and then understands it also. So the message, and it understands it's for me and not for someone else. There is all of that, right? So hence there has to be some kind of custom communication messaging protocol for server and device to communicate, right? And the communication manager needs to control needs the main controller needs to speak to the communication manager. So from the main controller perspective, the main controller should be able to tell the communication manager, hey, can you send this message? Can you do you have a message that you've received? Uh, are you connected to the server? Or when I sent a message to those, when I send a message to the server, did the server get it? Right? These kinds of questions the main controller would ask the communication manager, right? And hence I've just mentioned that here, right? Clear? Any doubts till now? Okay. Anyone else? Anything? Okay. Now we'll move ahead. So we've said this is what is needed, right? Uh, Now let us say we are gonna connect through a Wi-Fi system. Okay, let's solve this problem first. Say I chose to connect to the internet using a local area network. I'm assuming the place that I'm going to be deployed in, there is going to be a local area network. And if it doesn't have a local area network, the person who's using my device has to have a local area network where I can connect and connect to the internet through that. So I'm choosing option one, and within option one also I'm going to use a Wi-Fi connection. Okay, and through this you can choose various different Wi-Fi modules that exist in the market. One of the common ones that exist is some ESP something, right? Which I'm sure you guys know of. So you can take a look at that and say, okay, this is the hardware device or the hardware module I'm going to use to communicate uh, there, and then you can figure out, okay, what is going to be needed there. So that's one piece of the puzzle, right? So let's say I'm just going to mark the ones that we select in green. Okay, so this is what I'm going to do, right? Huh. I'll get to the second point later. Okay, I'll get to this point later, but let's look at this. Okay, these things. So now I know that the communication manager needs a way to send a message, needs a way to receive a message, needs a way to detect if the message was received or not, right? So if I look at the communication, and this needs to be called by the main controller. So it's going to be called by the main controller. So this communication manager is going to need to expose some kind of software API, right, or set of functions that can be called in my main controller code, right? So one function I need is to send a message. Okay, so I'll say, let's say call it, I'm saying there is going to be a communication manager send message function. Okay, so now I'm saying is the software API, so software interface slash API exposed by the communication manager. Okay, so I'm saying communication manager needs a function called send message. So in this send message, right, uh, what is my input going to be to the send message function? Uh, right, this is something that I need to think about. Correct? I need to think about what is my input. So for sure there is going to be the message itself, right? There is going to be a message that is going to be sent via the send message function, right? And the other thing that needs to be there is one thing could be is maybe the server that I want to send it to, right? Uh, Maybe I don't need that information. Maybe I can do it separately as well. I could first create a connection, and then after creating a connection, I can say, via this connection send the message. But whatever it is, I will need the server whom I need to send the message to, right? Anything else? This is the input that I need for send message. I'm just looking at it very minimalistically. Yes, when you actually write code or when you write it in terms of like a proper interface and software API and actually sit and write the code or a header file to look at it, it will be a little more detailed, right? But just so that everyone's understanding and we can, think through this quickly and have a detailed conversation. I'm just keeping I'm not, this is not syntactically correct for any language. It's more of a pseudocode, right? So I need the server ID or info, right? Where I'm going to be sending the message, and I need the message that I need to send. And I need a response saying, which is maybe a status. Okay. And this status effectively tells me whether the message was sent, not sent, right? Or there was an error sending the message or whatever, what have you, right? Correct? Okay. Now the second thing, so the first criteria is met by this pseudocode, right? Where I saying my software interface needs a function called send message, right? The second requirement was receive message, right? Receive message uh, has two parts to it, right? I can only receive a message when I know that there is a message that has come, right? And then I can read that message, right? That so it could be broken down into two parts. One is the interface could give me a function or an API or an interface that allows me to check if the communication manager has any message that it's received from a server, right? And if it has a message, then I could read it. So it could be two parts like that. Uh, Another thing could be, no, I'm not going to do it in two parts. I can say just boss receive message, and if it's there, it's there. You get it. If it's not there, you get back a status saying there's no message. So that could be a way of doing it. But I don't know how many messages are there because server could send 10 messages, and if I'm continuously going to be checking like this, that is going to be a problem as well. Another option could be I could so I have so let's let me just write this down. So receive message. We've discussed one option. Okay, one option is um, one function to receive slash read the message, and that behaves in the way that if there is a message available, we will get it uh, in the sense that the function will return it. We will get it, right? And if no message is there, the uh, function will say no message available, right? I could break it down into two functions where I say one function tells me if there is a message, and if yes, if there is a message, how many, and maybe how many messages have come from the server. And the message, second function, second function is to read the message. Alright. I could have a third option. Okay. Third option would say that the main controller in this option, in these first two options, okay, what will the main controller have to do? Main controller will have to say, communication manager, कोई message है क्या? And we'll have to keep on asking it, maybe at a set time, or in a loop. Okay, कुछ message है, 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 and it's basically going to keep on asking, keep on asking, keep on asking, keep on asking, right? And this method of doing things is called polling, right? So the main control system that you have in your main controller, which is your main FSM, is going to keep on asking. Your main loop, that is going to be your main code, is going to be what? Communication manager, do you have a message? No? Okay, I'll do something else and then come back and ask the same question. Or I'll wait, I'll go to sleep for 10 milliseconds or 30 milliseconds and then get up again and then again ask you the same question. Do you have a message for me? Do you have a message for me? Do you have a message for me? And communication manager might say, कि नहीं है जो भी, right? But I'm gonna keep on asking in both these cases. If I have one function also, if I have both functions also, right? Uh, Another option could be is the main controller says that, yeah, I'm not going to ask you again and again if there's a message. Anytime you have a message, please call so and so function that I'm giving you. Okay. So what the main controller will do is register a function. So the third option could be um, whoever is using the communication manager, not necessarily the main controller, but whoever is using the communication manager, because now communication manager is a module that I'm going to be using, correct? So whoever is using the communication manager, in our case is the main control block, is going to be saying, hey, whenever you have a message, please call this function that I am registering with you, right? So this could be a way of doing it. So we have three ways of doing it, and you could choose. There are pros and cons to all of it. You can get try to understand what would be the better way of doing it and things like that, and you can choose what you think is good for your system, right? Um, so this is the way you could do it. Now let's. So currently I've solved these three things, but there are certain things as well that how am I actually going to detect if the server's lost connection is a thing that I need to think about, right? Uh, Here I'm saying detect if it received or not, but and this API is going to give me this status through whether it received the message or not, but how am I actually going to do it, right? And all of this, how the send message is going to internally work, how the receive message is actually internally going to work, and how I'm going to detect if a message was received or not, and if there's a problem and all of that depends on item number two, which is the messaging protocol, correct? Uh, how do I talk to you, right? If I'm talking to you in English and I want to say that you've done something wrong or I've done something wrong and I want to apologize for it, I'll say sorry, right? In Hindi, I will say maaf kar do. So what I say and what how I do it depends, the norm in India as a cultural norm could be very different than a cultural norm in the US. So it all depends on the protocol and what people are used to there. So same thing here. Because two devices are going to talk, the two devices need to define how they're going to know something bad happened. uh, when I send the message, what is the way of sending the message? What is the way of receiving the message? The internals, what is the format of the message so that I know this is a message or not, right? All of that. And that is going to be part of defining your messaging protocol. Okay. Any doubts till now? Anyone? Okay. No one's written anything. No one said anything. So we'll move ahead. Okay. So I'll just we'll revisit this API that we exposed. Okay. After we've solved this problem now. Now you see why this is important for you to solve before you get here, right? Before you define this API. Because there are certain things that depend on the messaging protocol, correct? So when you're thinking about this is a topic that I was going to capture in the communal networks class as well, but session that I was going to take. But since a lot of the block diagrams that you guys have and are going to be building or have some kind of a communication manager involved in it, right? That's why I chose this example so that a lot of the projects that are having this piece can actually use the discussion that we have today and solve your problem, right? Now, let us look at beam messaging protocol, which was the third piece that the communication manager needs to solve. So, uh, let me just summarize this in a better slide here. So what I'm saying, CM's module summary. Okay, when I'm doing the detailing, I need to detail the hardware which will be used, right? I need to detail. Okay, I'll just be back 2 seconds. Hello. Okay, I'm back. Uh, so where was I? Uh, So we are saying hardware which will be used, which is basically the first part, right? Uh, the actual physical connection, how is that going to be done, and all of that. Then the second part is the messaging protocol, and the third part is the software API dash interface that is going to be there, right? This is if I answer these three things, okay, I am I've done the detailing of my communication manager. Okay. Uh, other than this, when we say hardware which will be used, there will be. So now I said that there is. I'm going to use a Wi-Fi module, right? And what was the Wi-Fi module I was talking about? I was saying we'll use. Let's say we're going to use ESP8266, right? So let's say we're going to use that. We decided that, and then the ESP8266, right? This is the Wi-Fi module we are going to use, let's say, and obviously there is going to be some software part which is like a device driver. So this is let me just so there is going to be the this is the actual hardware. And then there is going to be the connectivity between hardware and controller, like microcontroller, right, which is part of the hardware. I think ESP8266 uses UART, right, and 80 commands. So this is what is going to be there. And then I'm going to need a software device driver to you so that I can use the Wi-Fi module through software code, right? So this is the detailing of that, right? The messaging protocol helps the messaging, and the software API interface is the API that the communication manager will expose so that the other modules in the system could access it. Okay, that is the summary that we have. Any doubts? Anyone? Everything making sense? What is software device driver? Okay. Uh, just by so let's take the example of the ESP8266. I might be wrong that it connects through Wi-Fi, might be something through UART, might be something else also. But because I haven't looked at the data sheets in quite some time, it's just off memory. But let us assume that whatever I've written is correct. Okay. You take the Wi-Fi hardware module, and we know that it is going to connect to the microcontroller through UART. Let's say you choose an ARM STM32F4 microcontroller. Okay, or the Discovery board, or let's say Arduino hardware, or Arduino also has ARM-based boards, or anything, whatever hardware microcontroller board you're using, right? One is the microcontroller itself, and then you're using a development board, right? So let's say if you're using the EduARM or the Hydra board, which is available in college, there you're using ARM Cortex M3 LPC1768. So depending on that, right, there is going to be a physical UART connection that you will be making between the Wi-Fi module and the microcontroller. But just by making this physical connection, the Wi-Fi module will not start working, right? You need to be able to, through software, uh, send commands over UART so that the Wi-Fi can connect to the local network, or which is hardware dependent, right? Like it's dependent on the hardware that is being used. So the hardware that is being used is Wi-Fi, right? And ESP8266 connects over UART. So effectively, you need to write some software code that will allow you to connect 8266 to the microcontroller, and through the microcontroller, you're able to connect to the device, get things done, send a message over the Wi-Fi, receive a message, what have you, right? So this is what I mean by the software device driver. Okay, clear? Okay. Now let's get back to the messaging protocol. Okay. Now this is a tricky one, which most of you uh, and I've seen over the last 2 years and now the third year that a lot of you get struggle a lot while defining this, right? Because you are thinking, sir, TCP से connect हो जाएगा, UDP use कर लेंगे, HTTP use कर लेंगे, and you'll make, so we'll use UART in connect, or we'll use this thing in connect. It's not about the underlying physically कैसे connect होने वाला है, right? Wi-Fi से connection होने वाला है, that's fine. But like I said, what is the message that you're going to send, that the server understands कि ये device से pump के related data आया, या what is the device data that the server is going to send the device, so that the device knows that okay, it's a message to switch on the pump, switch off the pump, which is very specific to your requirement, right? uh, Underlying you might be using TCP, UDP, whatever, right? So but on TCP को भी जब बोलोगे send data, what is that data going to be looking like, so that both sides understand, right? So that's what we're going to do. So The way I like to think about this is the way I like going about it is the first question I want to answer is this going to be connection oriented or connectionless? Okay, connection or connectionless. What I mean by this is will the device or the server first need to uh, establish a connection between parties, like know that okay, who's connected to me before it can send a message to that device or to that server. So, for example, say the server or the device had to actually send a message to the server that my give a status to the server that my pump is on, right? So can the device just say send message to server one and just send it, right? And then there's no need of first doing this where the device says that hey server one, are you there? And then server one comes back saying yeah, I'm there. Okay, so now let's this is so now that I know server one is there, then I actually send a message, hey server one, my pump is on, right? So this is what I want to be solving, right? Whether I can do whether I'll do one or two. So one is just send the message and hopefully server one is there. So if it gets it, I know. If it doesn't get it, I know, right? Or maybe it gets it, doesn't get it, I don't know at all, right? So this is what I mean by connection, less or connection oriented. Now how do I decide which one I want to go with, right? Let's look at the problem. Okay, my system highest level is saying through a mobile app, the server is going to connect to a device, right? And the first thing that needs to happen is the server really needs to know which device is there connected to it. No, there could be three devices, four devices connected to it. Right now, the system is simplistic, where there's only one device connected. But even if it is there or not there, how will the app know or the server know that this device exists also, right? So unless the device connects to the server and tells the server that this device that I'm there, the server will not know that this device exists, right? Another way could be that no, server will know because whenever a device is deployed in the server, we go and do an entry that so and so device exists, right? That could also be a way. I could say, okay, no, the way I'm going to work is every time I deploy a device, I'm going to go into the server and put in an entry saying that, okay, so and so device one is so and so, right? But what did I do? So when I did my when I went to choice number one, okay, I said my device is going to be connected to a local network, and then within the local network, from the local network, we're going to connect to the internet. Um, so the server, the server really doesn't know details about my Wi-Fi module or how I'm connected to the local network and then connected to the internet, right? It's not like my device is publicly known. It's not known publicly, correct? My server could be known is known publicly because my mobile app always connects to the server. So my server is known publicly and will have an address or will have a location which is known by the public. But my device will not because of the choice I made here, right? Hence, the device is never going to be publicly available where the server can start communicating with the device. The communication will always be that the device will communicate first with the server and then the server can start communicating with the device, correct? And hence, just because of these choices that I made, right? My system has to be connection oriented, right? And the connection is going to be started by the device. So the device will trigger the start of the connection by sending some kind of message to the server that saying that hey, I'm there, and let's let's start talking on this connection that I'm going to make with you. And the server says, okay, now if I want to speak to you, I'll use this connection and speak to you. Correct? So think of it as like a phone connection that's made, and now anytime I want to speak to the server wants to speak to the device had the number of the server, but the server didn't have the number of the device, right? So the device called the server and said, boss, and the server doesn't even have caller identification, caller ID nahi milta server ko. So the device called the server and said, give us, I'm here now, I'm gonna speak to you through this, thanks for picking up my call, I'm gonna speak to you. Don't hang up the call. Every time you wanna speak to me, just send it through this call that anytime you wanna speak, just uh, talk here. So now the का server has dedicated some resources of its, so एक फोन उसने डेडिकेट करके रखा हुआ है कि अब डिवाइस ने इस पे कॉल कर लिया है तो अब इसके साथ मेरे को कंटिन्यूअसली इसी के ऊपर बात करना है. करेक्ट? Is it clear to everyone till now? Making sense? Devices, mobile is also not directly connected to server like that, right? Because मोबाइल नोज द सर्वर्स. सो मोबाइल एंड डिवाइस के लिए दोनों के लिए सेम सिचुएशन है ना. मोबाइल knows the server's number. Device also knows the server's number, right? Just because the server is set up in a way where uh, the server will have a public IP or a public address, a public number. Okay, uh, through which the mobile can actually connect to the server, because the mobile app, okay, you download it, let's say from Play Store or whatever, then we'll ask you to log in or whatever. So the mobile app, the source code within the mobile app will connect to the will have the address and the details of who the server is, where to connect, and things like that, right? Think of it like this. Now, when you open the browser and you type in google.com, google.com doesn't know your machine, who it is beforehand. No? Google.com didn't start the connection with you. You started the connection with google.com. You sent out a message to google.com, okay, hey, can you open up your search page, whatever. Same thing with your Google search app on your mobile phone. When you open up the Google search mobile app, what is happening? You are, through the mobile app, you are sending a message to the server, correct? So this the connection physically is never direct, right? Internally there could be various different devices and wires and all of that, that is, connecting your mobile app to the Google server, right? But who started the connection? The mobile app started the connection. Same way in this case also. Okay, I, because of the choice I made where my device is going to be on Wi-Fi, right? And I'm going to not give the device a constant, and it's going to be part of a local area network. And because of the structuring there, it's a more detailed discussion on how TCP, UDP, and internet protocol and all that works. Not getting into all of that. The server will never know the address of the or the number of the device. uh, it might know that okay, device ID 1 है, 2 है, 3 है, मैंने 3-4 devices छोड़ के रखे हुए हैं, right, market में. But it will never know where to call or who to connect to. Okay, so server can never trigger the connection. Hence, the device will always have to start the connection, right? And since the server cannot trigger and send any data, once the device sends certain data to the server, it needs to maintain that connection to actually keep sending it data. Okay, clear, Abhishek? Okay, so we are saying we're going connection based, right? It's going to be connection oriented, right? This is something that we are solving. We are saying that it's going to be that. Now, or let me just highlight it so that we put up the choices there. Now let's say, how do I get to know the number of the device or the address of the device or the server and things like that? What is my what am I going to be doing there, right? How do I know what is who am I calling? Right? I said the device is going to be calling the server now. And the device is going to be triggering the server that it needs to connect to. So I need to be solving one thing, which is how am I going to address things? How do I know device one is device one, and how do I know device two is device two, and how do I know this is the server that I need to connect to and not someone else and things like that, right? Uh, since I've already said we're going to use the internet and all of that, we are going to be, hence, there also the choice is already made for you. You are going to be using the internet, right? Internet is to be used, and hence you're going to be using the internet protocol, which is IP, and hence your level one addressing, like your base addressing of figuring out which server and which device and things like that is going to be via the IP address, right? So this IP address is going to be fixed for the server. Server will have fixed address, and it will be publicly known also. Public as well. Public in the sense that it's an address that can be accessed from anywhere, right? The devices will have a local IP. It will not have a public IP, right? You cannot, you just cannot connect to the device from just randomly anywhere, right? Because the device is going to be connected to a local network. So this is also solved. But even then, uh, I need to be able to, when the device connects to the server, right? It needs to be able to tell it it's device one, device two, device three, or something like that. So this will depend. So I need to give it some. I need to give my devices some addressing, right? Okay, this I need to be able to tell. And let's assume right now one device is mapped to one pump only, right? That one device only controls one pump. So I need to be able to say this is okay, pump one, pump two, pump three. Which pump am I actually speaking to? The server needs to get to know that, right? So think about it like this: the device called the server, and the server picked up the phone. Server said, "Okay, who's speaking?" So the device said, "Okay, I'm device one." Uh, Device one said, the server said, "Okay." So now this phone through which I picked up the call, that is dedicated to device one. Then device two called, and there was another phone that I used for that. Right. So now I have two phones through which I can call to device one and call to device two. The mobile app may I need to show that okay, there are two pumps, pump one, pump two, and through pump one I can connect to I can switch on pump one or pump two, right? So the mobile app will say what? Switch on pump one, and the server will say okay, pump one, switch on the uh, switch on. The device side should know कि okay server ने जो मेरे को मैसेज भेजा ये मेरे लिए था कि किसी और के लिए था. So there is some kind of addressing that I will need at my layer over the IP addressing, right? Over the IP addressing, which is to connect to the server and things like that, there will be some addressing that I will use. This will depend on how now the question is how many devices do I want the server to be able to handle, or how many devices am I going to deploy eventually, right? Say I say, okay, okay, a device will, I will have maximum, my maximum is going to be 50 devices across a field, right? 50 से ज़्यादा होने ही नहीं वाला है, you know. So I can use just eight 1 byte to uh, give an ID or unique, मतलब to give a unique ID, give an unique ID or address if you might call it, to any device, and this is how I am addressing the devices through a unique ID, which is 1 byte long. So because it's 1 byte long, I can effectively do 128, and hence I can do 128 different devices, right? So this is how I'm solving addressing. So the second part was addressing, and this is what I'm going to be doing, right? So first thing I'm saying, okay, connection oriented to होना है. Addressing में, because I'm using the internet, underlying the IP addressing होगा ही. But over and above that, I need to be able to uniquely identify the device. So I'm going to, so within my protocol, within my message, there has to be a way to identify the device that was doing the work, and hence I'm going to use 1 byte of uh, 1 byte. 1 byte is going to be the amount of data I'm going to reserve for, the size of the data I'm going to reserve for the address, right? Make sense? Everyone with me? Any doubts? Okay. Now, what else do I need to be thinking about? Now, the final thing I need to be thinking about is the messages itself, right? The structure of messages itself, like whether you know when I'm sending a message from the device, let's say to connect to those. Okay, the other thing is, sorry, let's before we do the structure of messaging and all of that, the next thing we need to think about is which is authentication and authorization. Okay, uh, device is going to be connecting to server. How do I know this device is the device that I put in to the field? Let's say this was an agricultural field. How do I know this is a device that is I deployed or it is a device that someone else deployed, right? How do I know that this device is authentic? This is my device. And how do I know? And then the other side of it, like from the mobile app side, someone comes in and says, shut down the pump, right? Completely, not just power off or on, like you just do a complete shutdown, okay, or change the parameter, like say pump make parameter hai ki speed with which it will, pump out water, right? And someone goes and changes that or things like that, and then later on and also maybe the pump has an auto start and auto stop feature where I say ki, okay, automatically start the pump at 2 o'clock in the morning, but someone goes and changes it to 4, whether that person is actually authorized or not authorized. This is something that I'll need from the mobile app perspective, right? So, and the device and the server should be able to say ki, Zain is authorized to do this or not authorized to do it, right? and authentication is from the device end as well as from the app end. Do I have if I'm using the mobile app, am I allowed to use a mobile app? If I'm uh, if my device is connecting to the server, my server should be able to say about this device is a legit device and is allowed to do it. So since we are only looking at it from the device end right now, authentication is something that is needed, right? There are fallback mechanisms, okay, generally come through redundancy. That is the only way you do it, right? So if you so there could be various to actually think about fallback mechanisms, you need to think about where all faults can happen, right, in your system. Uh, Whether a fault can happen, what are the points where faults can happen. Then you think, uh, are these points where a fault can happen, are they single points of failure or it can survive a single fault, right? Uh, then you think, कि, okay, if it is a single point of failure, how do I go about changing it, or what do I do? How do I add redundancy so that it doesn't become a single point of failure? For example, in this particular scenario, one single point of failure is your server, right? Say there was only one server, and then say the server got is lost or shuts down. Okay, uh, even then the system will break and will not work, right? So one option to solve this is that okay, I'm not going to have one server, I'm going to have two servers, right? And the device knows that okay, either I connect to server one or if server one के साथ connection नहीं हुआ, then I'm going to connect to server two, right? Or I could say कि नहीं नहीं, वो भी जरूरत नहीं है. Server 1 and server 2, both of them are sitting behind like a load balancing server, and device just knows the details of the load balancing server, and then the load balancing server can split it. So, and the load balancing server is also load balanced because, and there are certain load balance servers ka setup there, and the device whenever it queries, and instead of me saving the server's IP address or something like that, I save the server's domain name, let's say google.com or whatever, and then my DNS server gives me a list of IP address or give me one IP address or whatever, and then within that I can solve my problem. Okay, so this is the way you would go about doing it, right? Uh, Then there is also information about within the protocol. So this is single point of failure. There could be a fault where I send the message and it doesn't get delivered only, but that's not a single point of failure. That could be because of थोड़ी देर के लिए इंटरनेट चला गया, right? Let's say my Wi-Fi router was just rebooting the Wi-Fi router that I'm connected to via the device. The device is connected to the internet via a Wi-Fi router, and that Wi-Fi router rebooted, right? And if that Wi-Fi router rebooted, then it's a transient fault. It's not a failure, right? So there I could just retry, right? And if I retry after let's say 30 seconds or 30 milliseconds or like 100 milliseconds, 500 milliseconds, my message might go through, right? And I will say, कि, okay, technically, this is the timings, and looking at the timing diagrams, I can say, कि, okay, I can if I try 5 times and after every 300 milliseconds, I will solve this transient fault that comes in. Okay, so it really depends on what problem you want to solve. So you'll have to do a detailed analysis of that, right? Which we're not doing right now. So moving back to the topic, authentication and authorization is something that I'll need to think about. So, and since this is connection oriented, right, I can do this authentication and authorization at the time I make the connection, right? So what I can say is, so now things are getting, so now I'm getting more into detail, right? So okay, I need a message. So now I know that I need a specific message for making a connection. Within that message that I make a connection, I need a way of authenticating the device, right? And since I'm going to be making a connection, right? When I come back to this API that I created, I cannot send a message directly to a server. I will have to first make a connection and then send the message over that connection. So my software API is going to change. You guys see the link, right? So this is there, and then now what you need to do is, now let's define the structure of the message. So let's say any message that you have, okay, is generally broken down into three parts. You have your header, you have your you have the data, and you have your footer. You have your footer. Now we're going to talk about the message structure, right? Message. This one smaller, so it automatically fits in that here. Fine. So this is the way it is going to be, right? There's going to be a header, there's going to be data, which is the actual data that you want to send, right? And there's going to be a footer, right? So what all do I want to be having in my header, right? One thing I know for sure is I want to be having, if I'm making a connection, I need to be able to say which message I'm sending. Am I sending a message for connecting? Am I going to be sending a message for which is just data that I'm sending, or a command or something like that? So my header will have the command ID, right? Will, because I'm going to be using the IP address to connect to the server, my header will not have details about the underlying IP address and all. However, it will have which device I'm sending it from, right? So whether, so I can have the device ID as part of the header, right? And let's say for starts, this is what I need. I need the device ID and the command, right? And now every command would have certain data associated with it, right? So let's say the command is to make a connection, right? So the data associated with the command is obviously the device ID, but then I said we need to do authentication, right? So let's say the way I'm going to do authentication, okay, is that I know that on the server, I know every time a device is going to be deployed, the user will come to the server and register a device first. And then once the device is deployed, it will, and the first message that it sends via connection will be uh, information that is generated or set up during the registration of the device, so that the server knows which device it is. For example, uh, you come into the server and you register the device. You say, okay, device one, register. Okay. And the server comes back and says, okay, this is the unique key. Let's say it creates like a key or a username password. Let's keep it simpler. Let's say it creates a username password for the device. So the username password for the device is device one is the username, and the password is device one at the rate 56434. Okay. Uh, okay. So now the header uh, will have the command, which is the connection command. ID तो मेरे को पता है कि device ID is there part of the header in the data. Now I need to say, okay, whether the username is going to be first or the data is going to be first or the password is going to be first, right? So I choose username to be first and then password to be first, second, and that I know because of my command ID. Because my command ID is one, which is a connection command, right? My data is going to be arranged in that particular format. And but how will my system know how long the data is? It could be username could be 5 characters, could be 20 characters, could be 30 characters. And password could also be 5 characters, 8 characters, 30 characters, 50 characters. So in my header, automatically, I need a way to say that okay, how big is the data field, right? And within the data field, I also need to know. So the overall length of the data is also part of my header, right? And so now if I just look at, if I now I'm just zooming in the header, okay? I'm saying header is going to have. This is just things I'm just thinking on the top of my mind. I might be complete, like once you analyze your particular thing, you might need to add few more things. Okay. So command, I'm saying there is going to be a command ID. There is going to be a device ID, and now you can choose which you want first. You want device ID first, you want command ID first, right? Uh, there are various other things that you should be doing to improve. And then I'm saying one thing for sure I need is the data length. Okay, how long this field is. So let me just do different colors so that this is data, this is footer is green. Yeah, let's make footer green. Fine. Data is gray, header is blue. So now this is the things that are there. So data length represents how much data is actually there, right? And this also now I put in a constraint when I've done it like this. Okay. When I've done it like this, the constraint is irrespective, and then depending on my data length, how many bytes I use here. Let's say I use 1 byte as data length. My data cannot be more than uh, 128 bytes, correct? Because data length is how many bytes are there in data. So if data length is 1 byte, so the biggest number I can go is 127. So hence data cannot be more than 127 bytes. Correct? Understood? So the same, so depending on how big I keep this, I constrain how big data is. Another constraint I put by keeping it like this is no matter what command it is, it cannot be broken down into multiple parts and sent. Okay? My command, whatever data it wants to send, has to be max 127 bytes, and it cannot be broken down into multiple parts as well. Because I don't have any way of figuring out whether the message is, broken down into multiple parts. Like, say the data was 200 bytes. I just can't send that message the way it is structured right now, because this was data length. Let's say this is equal to 8, well, the 1 byte, then the max size is 127. And if I wanted to send data which is 200 bytes, just not happening because I don't know how I'm going to break the data into multiple messages. So I don't have a feel, I don't have a way of doing it. And maybe that's good enough for what you're doing. So you don't need to have that, right? Another constraint that you're putting in is you don't know, so you will think about it a little bit further, right? So this is what it is, like this is the way you could do it. And then depending on the command ID, your data structure would be different, right? So because it's command ID connect, first 8 bytes will always be username, second 8 bytes will always be password, and that's the way I can do it, right? Doesn't matter. Fine. Any doubts? Anyone? Nothing? Okay. So now you get an understanding of how I want to break this down. There are various things that you might want to add. You would want to say, okay, this is fine for today, but let's say tomorrow I come out with a new version. So maybe I want to add one byte or one nibble as version ID, okay, of this protocol. So that tomorrow, if I want to change data length from 1 to 2, I can do that, and based on my version ID, I can figure out whether this is version 1 of the protocol or version 2 of the protocol and things like that. You can add in your footer things like CRC checks, right? Whether the data that I've received, is it valid data? My CRC check, error control checking is valid and things like that. So you could do basic parity based CRC, or you could do something else there and have that information in your footer. Uh, you could say you wanted to send this data over. So this would depend on what you're sending it over, right? But let's say you're sending it over UART or something like that, where there could be noise in the wire and something like that happening. You might want to have like a start of message byte in your header and a end of message byte in your footer, so that you know that everything within this is actually your message, because there's no way of figuring out where the start is or end is. But in TCP it doesn't matter, or TCP UDP, if you're using it, it doesn't matter. But something like UART, you'll need to think about those things as well, right? uh, so what you have in your header really depends on what all you're gonna do, right? And this is just a basic message structure. Obviously, the detailing of your header and the detailing of footer needs to be done to complete the messaging protocol, right? Now, coming back to, just because we have time till 7 in this software and all of that, I think this is covered, and you can drill down and actually now start thinking, और क्या हो सकता है header में, right? You will have, if you want to be able to send, can I send multiple commands simultaneously? Right now you can't with this structure, because uh, whether you could, then it depends on how I'm doing acknowledgement, right? Depends on how I'm doing my status. If I'm sending the uh, say I send command 1, and then I wanted the response to be an acknowledgement, or any command I send, I want the response to be an acknowledgement. Then how is my acknowledgement message, or so the command ID would be acknowledgement. And then if the data has which command ID still doesn't work, I could be sending the same command ID twice. So then if it's for command ID, like for example, let's say I sent command 5 from the device, from the server to the device. The device took that and sent an acknowledgement saying that I am sending acknowledgement for message 5. But let's say the server sent two message 5s simultaneously. Okay. Uh, and then it sent a 6. Whether the acknowledgement was for 1, for 2, for 6, unless you have the command ID within the acknowledgement structure, you can't really know for which message it was the acknowledgement, correct? So maybe you cannot send multiple messages simultaneously to the same device without getting an acknowledgement back. You might say that works for you. If you say, no, no, I want acknowledgement, and then I want to know which message got acknowledged, you can do that as well. Your structure of command ID, maybe your header changes, maybe the way you arrange your data, that changes, right? Now moving back to our software API. Okay, so software API. Okay, now we know that because of this exercise that we did, uh, we know that the API is going to require. Actually, another thing that I also know is that the communication manager, there is only going to be one. communication manager. There are not going to be multiple communication managers, right? So uh, I know it is a singleton. It's like a single entity, right? And I'm not going to be creating multiple communication managers within my system, right? Whereas pump, okay, if the device was managing multiple pumps, then for every water pump, I will have one pump controller, right? So then I would have multiple instances of pump controller. You get what I'm saying, right? But in our case, the communication manager is only going to be one, which is always going to connect to a server, right? And this is the one that is managing communication with the outside world. So this is always going to be one, right? So there's only going to be one instance of it. So so now if I go into my software API, the way I would do it is uh, there is going to be there is I'm just going to say CM underscore. There's going to be an initialization function to init the communication manager, which is tell it. So in this, because if you want to do this right, uh, because we chose Wi-Fi, but tomorrow I might want to choose GSM as my underlying, and you want the communication manager to be, exclusive of that and doesn't care about what is used internally, you could give it configurations of the underlying thing that you're using. So you will have reader and writer functions which are registered during initialization. Okay, then you would have uh, connect function. Okay, so this is communication manager connect. Communication manager connect will need the server info जिसके साथ connect करना है, right? And this will return a connection object, right? Some kind of connection object, and then your connection manager will do a send data or send message or whatever via. So we'll use a connection object, right? And a message as will be its input, and you could have, if you wanted to do the if you wanted to do option 3, you could do that, or option 1 or 2, whatever. You could say okay, has message over a particular connection, right? And this could be just a boolean that is responded saying that yes, no, there is a message. And then you can have a read or receive message, which will depends on how you want to do it, pointers, things like that. But what will get responded is you need to have two things. One, you will either get the message as a return, or you will get status. And obviously, you don't want it to be blocking on a message forever, right? So you might want to say, give me one message or two messages or how many messages. So you could say message count. This is still not the header file. Obviously, when you actually create the API, this thing, header file with proper C syntax or something like that, you can mention, right? And maybe a timeout कि इतने टाइम में मैसेज मिला तो ठीक है, नहीं तो निकल जाना, right? Other, or you could just say no, receive message blocks. है मैसेज है नहीं पता, रिसीव मैसेज जब तक मैसेज नहीं मिलता ब्लॉक करेगा, right? And then hence you have to use has message before receive message. So it depends on what you want the users to do, right? And the user who's going to use this software API, which is the person who's going to write the code for the main controller. So he's going to be using this API, and then you might have connect communication manager register receive message handler, where you take in the connection object and you take in the callback function. So now every time there's a message that comes to the communication manager for a particular connection, it will call this function, right? It will call this function, callback function, because this was registered, right? So this is what you can do, and then you can have, so like you have connect, you're gonna have, obviously you will need a, you're gonna need a disconnect. Okay. Think about this. I just need to be back in 2 minutes. Okay. Okay. So this is minimalistically this much is required, right? In my innate, I might have other things like, okay, internally, how many messages can I store? Because if the user doesn't call receive message, the user meaning the main control doesn't call receive message at all, then obviously I cannot keep old messages forever, na? So how many old messages I'm gonna keep? All of that would be configuration parameters, right? So this will be having some config parameters. So the config parameters would be if I'm receiving a message, if I don't call receive message and the server sends me 20 or the device sends me 20 different messages or the server sends me 20 different messages, uh, and I don't read them only, what am I going to do, right? What is going to happen there? How many messages? 20 messages, 30 messages, one message, and then after that I will not take any more messages. What is that size? How big is that going to be? Correct? So, and I'm sure when you guys think a little bit more, you'll get many more things that you would want to have as part of the software API. You didn't understand register receive message function. Okay. When we did this, I said there are three ways. No, one could be the function which is receive message is implemented in a way that you tell it, okay, give me one message, and it works in a way that okay, अगर message है तो दे देंगे, नहीं है तो वो बोलेंगे कि error है, message नहीं है. Another way could be कि no, receive message doesn't give you any error and all, it just blocks. कि receive message will always block and say कि okay, जब तक message नहीं आ जाता तब तक response ही नहीं देगा receive message. And hence you will have to call something like a has message, which will first you check कि कनेक्शन पे कुछ मैसेज है क्या, एंड अगर है then receive message will give a return. Okay. Another way, so but if you think about the person who's using this software API, उसका कोड कैसे होगा? While communication like check if communication message communication manager has message, then receive message, then do stuff, and then again come back and then say कि okay, मैसेज है क्या नहीं है, तो फिर अगर ठीक है थोड़ी देर go to sleep for some time and then come back and check if the message is there, right? So this way of doing things is called polling. You are continuously asking the communication manager, message है क्या, message है क्या, message है क्या. Communication manager will eventually say yes, yes, there is a message, and then once it gives you that message, you work on that message, and then again go into this mode of message है क्या, message है क्या, message है क्या, message है क्या. Another way of doing it is the main control application that you have doesn't do all this message hai kya, message hai kya, message hai kya. It is nicely chilling, relaxing, and not doing anything. Suddenly the communication manager receives a message, and every time it receives a message, it pings. the user who needs to know whether the message that a message has come, right? So this is what this register receive message handler is for. That anytime, so whoever is using the communication manager can say, "Ki, okay, I'm not going to ask you again and again if you got a message. Anytime you get a message on this particular connection, you call this function of mine, call this function of mine that I'm giving you. I'm giving you this callback function. You call it, okay? And when you call it, I will do need what needs to be done. Okay, make sense? Okay. Anyone? Any doubts? Okay, no one has any doubts. So to summarize again, okay, any module that you do, you will need to be doing this and you will need to be doing this. This is very specific to the communication manager, correct? Hence it exists. There could be certain things specific to a different module that you're using, hence that might be there. But effectively, you need to define this and this, and within this, there is going to be these three parts, right? This is more about writing the device driver and things like that, but you need to know how it is communicating with the device, with the microcontroller, whether it's going to be over UART, what it's going to be, right? And the internal hardwares that are going to be there. Fine? Make sense? Anyone any doubts? If you have a doubt, you can type it in the chat. Okay. If you don't have a doubt, you can. We're done. We can end the call. Okay. Uh, I'll wait for like 2 minutes if everyone's if no one has any other doubt. Okay. I will close this out.
Mm. Students, if any doubt, please ask, or we close the session. Okay, sir, we are good enough to close now. Questions.
Okay, fine.
Thank you, sir.
Thank you. Okay.
Yeah.
Bye bye.